Now let's watch it. See, it is Peterson's method. Till now, whatever we have seen, either lock or turn or interest rate or any other methods like disabling that interrupts. All these methods have one disadvantage or the other. I mean, if you look at the four conditions, none of these methods have really satisfied any of these all of these four conditions, right? But this is the first method which is proposed by Peterson, which is a combination of two variables, turn and interest rate. I'll show you how. And this is the first method which is used at the user mode. User mode means we don't need any support from the operating system, therefore it is platform independent, which means it can run on any operating system because we are not taking any support from operating system. And then it is a busy waiting solution, and it is applicable for two processes, right? So this is the method using which or the first method using which we are able to implement a synchronization mechanism with all the four conditions being satisfied. It is very simple, and everything executes at user mode. Therefore, there is nothing overhead, no overhead for the operating systems. We don't expect anything from operating systems. Okay, I'll just explain you this algorithm, and then I'll take two processes and I'll trace out what happens to this algorithm if if two processes are going to run at parallelly. Now let's see this. The algorithm is like this. I mean, this is entry section. I think you remember this. So whenever you want to enter into the critical section, you have to first write the entry and then write the exit, isn't it? So entry section, we are going to write it first and then enter the critical section and then exit section. This is what is the synchronization mechanism. Now in this algorithm, we are going to show what should be this entry section and what should be the exit section and what should each process. Here I am assuming that there are two processes, and the two processes are like this, P0 and P1, which means one process ID is 0 and other process ID is 1, right? So now I'll show you what should each process execute before they enter into the critical section, which means the entry section, and what should they do after they exit the critical section, right? Let's see this. Hash define n as 2. It means that the number of processes which could use this solution is 2. That is what the meaning of it. And hash define true as 1. These are all the constants. Hash defines are nothing but the preprocessor directives which are used to define the constants, which means wherever you see n now, it is always you assume that it is 2, and wherever you see true, it is nothing but 1, like that. Now I am saying that number of process n is 2 and true is defined as 1 and false is defined as 0. Int interested of n equal to false. It means that I am assuming that all the processes are initially not interested. So what is interested of n? Interested of 2, isn't it? Which means interested is an array which is having two variables, I mean two elements, interested of 0 and interested of 1, because n is 2 and both are initialized to false. What does it mean? Initially no process is interested in getting into the critical section. That is the meaning of it. And then in turn, so turn is not set, turn is a random number here. I mean initially it is not initialized. In turn means turn means that whose turn it is to enter the critical section. We are not going to define it at all. We are going to leave it free. Now void entry section of int process. So if this function is executed by, let us say, P0, the process P0, then this process will take 0. This int process will take 0. In case if it is executed by P1, then it takes 1, right? Int other means if it is called by P0, then process ID will be 0, and what will be the other process? Other process will be 1 minus 0, which is nothing but 1. So the concept of the process and other works like this. If the process is P0, then the process which is calling this function is P0, then the process number will be 0, and therefore the other process number will be 1 minus 0, which is nothing but 1. That is how it works. Are you understanding this? See, the beauty of this concept is, if P0 calls it, then process number will be 0. Then what about the other? Other will be 1 minus 0, which is 1. Similarly, if P1 calls that function entry section, then process this integer will be 1 and the other will be 1 minus 1, which is 0, right? Therefore either P0 or P1, whoever caused this entry section, they will be able to figure out who is the other process, right? If it is 0 is calling it, then the other will be 1. 1 is calling it, then the other will be 0, right? That is the beauty of this line. Simple line, right? And next one is, since you want to get into the critical section, just say that you are interested, which means interested of process equal to true. In case if it is called by P0, then interested of 0 will be true, which means it is showing that P0, P0 is telling that I am interested in getting into the critical section. And then it is funny, see, turn equal to process. See, previously earlier what happened is, we have decided the turn, and that is how a process enters the critical section. But here, a process which is interested in getting into the critical section, it itself is declaring that it is my turn to get into it, isn't it? So it is funny here. See this, now it is saying that turn equal to process. It means that it is saying it is my turn to get into the critical section, right? Okay, how does it work? I'll show you how it works. Initially we are saying that I am interested, and then we are declaring that it is my turn to get into the critical section, right? And then it is cautious in such a way that if other one is also interested, then maybe that process might be in the critical section, then I'll wait. Okay, see this, what it will do is, while interested of other is true, which means if the other one is also interested, which means if the other process has also run this line, which means other process also has tried to enter the critical section. Therefore there are two choices, two chances or two possibilities. When the other process is interested, either it is already in the critical section or it is still somewhere here, isn't it? So which means other process has just crossed this line, which means either the other process is there somewhere here or it crossed it and it is inside the critical section. Then what I do is, safely I assume that the other process might already be in the critical section, therefore I will wait. So see this, while interested of other equal to true, which means other one is interested, and turn equal to process. Turn equal to process means I am the last one to set the turn value. Okay, I'll again explain you with an example, right? So don't worry, I'm just trying to explain this algorithm. Even if you don't understand it, I'll take examples and I'll make it very clear. So for now, understand that this process, one particular process, is just thinking that other process is already interested, and turn equal to my ID, which means other process has already set the interested value as true, and then it might have made turn equal to process, or I don't know, but then I am the last one to have updated the turn. Then I'll wait. Why? Because the chances are that when the other process is interested, that process might have already crossed this entire part and it might be in the critical section. Therefore I'll wait in a infinite loop. Till what time? Till the other process comes out and makes its value as false, which means, see this, but how long are you going to wait? We are going to wait till exit section is exit of in process. The other, exit is nothing but you should show that I'm not interested anymore, which means once you are reached here, you should say that I'm not interested, you can get in. Okay, that is how the algorithm is. I don't think that you understood anything here. I'll take two processes and then I'll show you what happens if they executed these statements in any order. Okay, I'll just show you in the next video. Okay.